In order to design systems using waiting lines or queuing theory, we will see some technical terms in this video. The first thing to understand is the simple idea that we discussed before. There is a server and there are some people or some information on some products which need some service, and they pass through that server and get that service. Now, this is a very simple definition of a waiting line. Real life waiting lines are more complex. So, for example, the line 1 that you see is a typical line that you could see in a checkout counter at retail stores, where there are multiple servers, multiple lines. The customers choose to stand in a particular line, get served, and leave the system. The line 2 is a line that you also see at a DMV or even the self checkout counter waiting line. So all the customers are in one single line, and then depending on which counter or which checkout counter gets empty, the customer is directed to that checkout counter. So it's multiple servers, single line. That's the line 2. Line 3 is also a more realistic line that we see in real life systems, where we say that, for example, when I go to a restaurant, I go and wait in the lobby where the host or the hostess, after some time, would take me to my table. Then I wait at the table where the waiter would come and take my order. And then my order goes and waits for the chef, and the chef makes it. The ready-made food waits for the waiter to come and deliver it to me, and so on and so forth. So there are multiple servers involved in that. So in these series of videos, we're just going to look at the simple scenario that you see top in the middle, a single server and single line. And all you need to understand is that the results we derive for that scenario are going to get exaggerated when we have all these other complex systems. And then before we end, some understanding of the distributions. So the inter-arrival time or the service time follow a certain distribution. Okay, I'll explain what the distribution is in a so let's assume we assume uniform distribution, and so we say that the inter-arrival time could vary between 10 minutes to 20 minutes. That's an assumption. Okay, we could have any other variation in our data, but let's say that it varies between 10 minutes and 20 minutes. What we're seeing here is the probability of customer taking any one particular unit of time is same as any other particular unit of time, the time between customers or the service time. So let's say I say that the probability of something taking say 18 minutes is so much. This height depicts the probability. So the probability of some service taking 18 minutes is so much. The probability that the service will take 15 minutes is also exactly the similar, right? The probability that service will take 15 minutes is exactly same as that. And same thing, and same thing for inter-arrival time, the time between two customers. Now, when I say that it follows normal distribution, what I'm saying is the probability of the mean value, which is also the mode and the median, let's say it is 15 minutes, is the highest. The probability that something takes 15 minutes is the highest. And the probability that a service could take, let's say, 18 minutes is lower than the probability that it could take 15 minutes. And same thing, the probability of it taking 20 minutes is even lower than the probability that, so same thing, the height depicts the probability. The exponential distribution says that more or less everything happens fast in low times. There is a high probability for low times, but for extreme times also there is a very small probability. And last that we will discuss here is a log normal distribution, where it says that most of the times, this is the modal value, most of the time it takes me 25 minutes to go to office from home. The probability that I do it in 10 minutes is very low. Okay. And there could also be a probability that I take 2 hours or 120 minutes because maybe there is huge traffic or there is some kind of I have a flat tire, and because of which I could take 120 minutes also in this scenario. So these are different types of distributions that could happen in our data. In these series of videos, we're just going to look at uniform and exponential distributions. And according to the type of distribution in your data, you can use the same type of analysis and create some kind of analysis and design for your operations or your process using these methods.